Hello students, so continuing our lectures on mathematical physics, uh, this is a Laplace transform. We'll discuss about Laplace transform here. So if there is a function ft, then the Laplace transform fx can be presented as ft into e to the power minus st, which is the kernel, 0 to infinity. And similar to Fourier transform, when you have a Laplace transform, you have an inverse Laplace transform as well. So if ft is the Laplace fs is the Laplace transform of ft, then ft is the inverse Laplace transform of fs. So that's how these two functions are related. Now we can have numerous functions and its corresponding Laplace transform. Like if the function is 1, then the corresponding Laplace transform is 1 by s. If it is t, then it is 1 by s square. And if it is a combination of two functions f1 and f2 having coefficients a1 and a2, then the corresponding Laplace transform will be f1 and fs joined by the same two coefficients a and b. Secondly, if the function is a into fat, then the Laplace transform will be the function of s by a. And if the function is e to the power at into ft, then Laplace transform will be a function of s minus a. If the function is f t minus a, where t is greater than a, then it will be e to the power minus as fs. So these are the different Laplace transforms. If the function is t to the power n minus 1 divided by n minus 1 factorial, then the corresponding Laplace transform will be 1 by s to the power n, where n runs from 1 to 3. E to the power at will give a Laplace transform 1 divided by s minus a sine at by a will give a Laplace transform 1 divided by s square plus a square cos at will give a Laplace transform s divided by a square plus a square sine hyperbolic at divided by a give a transform 1 by a square minus a square, and cos hyperbolic at will give a Laplace from s divided by a square minus a square. Okay, so we now move on to the next topic, that is calculus of variation. Now, the calculus of variation is concerned with the problem of finding a function, yx that says that a definite integral taken over the function shall be a maximum or minimum. A definite integral taken over yx will be an extremum, that is either minimum or maximum. So let's I represent it as that definite integral x1 and x2 y f function of y dash into dx, and to have a stationary value, that is to have an extremum value, the integrand is to be taken a function of a dependent variable y as well as the independent variable x, and dy by dx. The limits x1 and x2 are fixed at each of the limits, and y has a definite value. The condition I will be stationary, so this will be stationary or extremum if it is given by the Euler equation. Says that del f by del y minus d by dx of del f by del y dash is equal to 0. Now, when x does not depend explicitly on x, then a different form of the above equation is more useful. So, when f does not depend explicitly on x, then a different form is del f by del x minus d by dx of f minus y dash df by dy dash is equal to 0 is applicable, and this in fact gives the result f minus y dash del f by del y dash is equal to a constant. So